हाँ तो गाइस देखते हैं ये क्वेश्चन नंबर 23 जो कि आया था सिविल सर्विसेज मेंस एग्जामिनेशन 2013 में 10 मार्क्स के लिए। तो ये एक थ्योरेटिकल क्वेश्चन है जो कि पूछा गया था। तो इस क्वेश्चन में यह है कि वी हैव टू डिराइव दिस expression that is given here. So the thing that is given to us, that is conditions, is it is a closed system and that is undergoing a reversible process. So for this, first of all, we have to draw a PV diagram. So assume that we draw a PV diagram. In this we take a cycle from A to B, B to C, C to D. So it is a cycle that is done by 4 process. First from A to B, then from B to C, then from C to D, and then from D to A. And in this, A to B and C to D are both isothermal processes, not A to B, C to D. Actually, any cycle, reversible cycle, can be shown using two isothermal processes and two reversible adiabatic processes. So instead of this whole cycle, we generally make this cycle made up of many different cycles. So we are assuming here that this whole cycle is also made up of a cycle that is from 1 to 2, 2 to 3, 3 to 4. And in this 1 2 3 4 cycle, process 1 to 2 and process 3 to 4. So this process 1 to 2 and this process 3 to 4, these both are isothermal process, and this process 1 to 4 and process 2 to 3 are reversible adiabatic process. Now let us assume that this cycle can be broken down into many different cycles. So this process can be broken down into smaller cycle. For example, we have broken down into process cycle 1 2 3 4. So we can easily calculate what should be the efficiency of this Carnot cycle. So we know that the efficiency of this Carnot cycle is given by 1 minus T2 by T1, and the efficiency, that is 1 minus dQ2 by dQ1, is given out to be 1 minus T2 by T1. And if we take if we further solve this, we can get this expression, that is dQ1 by d minus of dQ2 by T2 is equals to 0. And we know that since the heat Q2 is rejected from the system, so this dQ2 we see here, this dQ2, this is rejected from the system, so this is taken to be negative, and this dQ1 is the heat that is given to the system, so this is taken to be positive. So with the efficiency formula we get this expression, that is dQ1 by T1 plus minus of dQ2 by T2 is equals to 0. Hence, if we further divide this ABCD cycle into multiple small cycles, we can get this expression for many cycles. So assuming we divide this cycle into many different cycles, we can get this expression, that is dQ1 by T1 plus dQ2 by T2 up to infinity is equals to 0. And if we apply this summation formula, that is I is equals to 1 to I is equals to infinity, dQi by Ti is equals to 0. This implies that integration of dq by t is equal to 0. And now if we consider a reversible cycle that is composing of two processes, that is the process from I to F, it is referred as R1, and process F to I is referred as R2. And we know that closed integration of dq by dt is equals to 0 in a cycle, that we have just proved in this expression. We can write that for process R1, integration of dq by t takes place from I to F, and for process R2, integration dq by t takes place from F to I. And if we take this expression this side, it comes out to be negative, and if we change the limit, then it becomes I to F. So for a reversible process, summation of dq by t from I to F is equals to summation of dq by t for the process R2 from I to F. Hence dq by t represents a property, so it becomes a property since it depends only on the initial and the final states. So property जो होती है वो डिपेंड करती है सिर्फ इनिशियल और फाइनल स्टेट्स पे. उसको आप किस तरीके से कमाते हो वो डिपेंड नहीं करता, वो सिर्फ डिपेंड करती है कि आपने कितनी प्रॉपर्टी कमाई है, ये जो आपके पास पहले थी और बाद में क्या थी। तो इस तरीके से आप याद रख सकते हो कि वो बीच के किसी भी प्रोसेस, किसी भी तरह से आपने कमाई हो, वो उस पर डिपेंडेंट नहीं होती है। तो ये जो सिस्टम है इसकी जो ये है वो प्रॉपर्टी है। तो इस प्रॉपर्टी को क्या कह सकते हैं हम, इस प्रॉपर्टी को कह सकते हैं एंट्रोपी। तो ये इस तरह से डिफाइन की जा सकती है। फॉर ए रिवर्सिबल प्रोसेस heat exchange that is dq in a reversible process at a temperature T, the entropy change ds is given by dq reversible by T। तो एक एंट्रोपी का कॉन्सेप्ट इसमें पूछा गया था, तो इस तरीके से हमने प्रूव कर दिया है। सबसे पहले एक बड़ी साइकिल ली ABCD, देन वी डिवाइडेड द बिगर साइकिल इनटू मल्टीपल स्मॉलर साइकिल्स 1 2 3 4, एंड देन वी use this expression for the infinitive series and get that the summation in a cycle is equal to 0. Then we take two process, that is process R1 and R2, and for this process we calculate what should be the change in Q divided by T, and this comes out that it only depends upon the initial as well as the final states and nothing in between them. It depends only on I and F, here also and here also. So it depends only on the initial and the final states. Now this property is known as entropy, and so for a reversible process the change in entropy is given by dq reversible by T, hence proved. Thanks for watching, see you next time.